Hello my scholars, you are welcome to my school channel and my name is Frank. In this lesson video we are going to be tackling JAMB CBT chemistry past question for the year 2008. Relax, do not go anywhere and we'll be right back. You are welcome back to my school channel. So in this lesson video, we'll be tackling question 1 to 25. So let's begin with question 1. Chlorophyll obtained from green leaves of plant can be shown to be composed of more than one colored component by the techniques of A. Crystallization. Okay, so crystallization is a method used to separate salts which decompose easily on heating. Okay, so A is not the answer to this question. Then B, we have hydrolysis. Okay, so hydrolysis is just the chemical breakdown of a substance when combined with water. Okay, and a good example that comes to mind here is the reaction of esters with water, okay, to produce organic acid and organic base. Okay, so B is not the answer to this question. Then we have C, chromatography. So chromatography is actually used to separate, or it is a method used to separate colored components. Okay. And D, we have sublimation. So sublimation is used to separate a mixture of, okay, a mixture that contains a substance that can easily sublime. Okay, so the answer to this question is chromatography. Okay, we know that chlorophyll is a mixture. Okay, so being a mixture, it can be separated by chromatography into its different components. Okay, so that makes option C the correct answer to this question. Question 2. In countries where the temperature falls below 273 Kelvin, salt is always sprinkled on the icy road in order to dash A. Lower the melting point of the ice. B. Increase the density of the ice. C. Make the ice impure. D. Raise the melting point of the ice. Okay, so the answer to this question is option A. Okay, so it's a well-known fact that the presence of impurity in a substance actually lowers the melting point of that substance. So in polar and temperate climates where the temperature falls below 273 Kelvin, okay, salt is usually or is always sprinkled on icy road in order to cause the ice to melt on time. Okay, so that makes option A the correct answer to this question. Lowers the melting point of ice. Okay, the reason why that salt is added to that ice is so that the ice can melt on time. Okay, so that the road can become usable, okay, in a very short time. Okay, so option A is the correct answer. Question 3. From the equation above, calculate the mass of sodium hydroxide produced by 2.3 grams of sodium. So let's move over to the board to solve this question. So according to the question, this equation was given to us. So from this equation, we know that 2 atoms of sodium, okay, actually reacted with water to produce 2 molecules of sodium hydroxide. Okay, one thing you must take note of is that in this question, our concern is only on sodium and sodium hydroxide. Okay, so this question is very direct. So here you don't need to solve for limiting reactant and stuffs like that. So you don't need it here. Okay, so but first of all, it is important that we know the relative atomic mass of sodium, okay, and the molar mass of sodium hydroxide. So we can calculate the molar mass of sodium hydroxide here. So NaOH, right? We know that sodium, the relative atomic mass of sodium is 23, then plus that of oxygen, we know that is 16, then plus that of water, and sorry, that of hydrogen, we know that is 1. So if we add everything together, that will give us 40 grams, okay, per mole. So this is the molar mass of sodium hydroxide, okay? While that of sodium is just 23, which is the relative atomic mass of sodium is 23. So we have 2 atoms of sodium here producing 2 moles of sodium hydroxide, okay? So 2 moles here is going to have a mass of 2 times 23, okay? And this will also give us a mass of 2 times 40. So this will give us 60. Now what this means is that 46 grams of sodium actually produce 80 gram of sodium hydroxide. So the question they are asking us is what mass of sodium hydroxide will 2.3 gram of sodium produce? So here we put your 2.3 gram. So what mass will it produce, right? So we just cross multiply. Okay, so we cross multiply. So if we cross multiply, we're having that the mass that will be produced, let's call here X. So let's say S will now be equals to 80 times 2.3 over 46 equals to 80 times 2.3 over. Now this 46, we can as well write it as 4.6 times 10. Okay, so the reason why I'm doing this so that we can easily divide without calculator. So 2.3 here is 1, 2.3 here is 2, right? So 2 here is 1, 2 into 80 is 40, right? So 0 here is, okay, 10 here is 1, then 10 here is 4, so that our answer becomes what? 4 gram. Okay, so let's move over to the screen to pick the correct option. So from our calculation, we actually got 4 grams. So the mass of sodium hydroxide that will be produced by 2.3 gram of sodium is 4.0 gram. Okay, that is 4 gram, right? So that makes option C the correct option. Now, but I want to point something out. Now, over to the board. So if you look at what we have here, since we are having 2:2, okay, 2:2 is still the same thing as say 1:1, because those two will cancel themselves out, right? So you can as well just go 23 and 40, okay, without having to multiply by 2 on both sides. Your answer will still be the same. So I'm just pointing that out so that you will not get confused about it. Okay, so that's that for this question. So the answer to this question is option C, 4.00 gram. Question 4. 16.8 gram of sodium hydrogen triisocarbonate 4 is completely decomposed by heat. Calculate the volume of carbon 4 oxide given off at STP. So we know that the molar volume of a gas at STP is given to be equals to 22.4 dm cube. So let's move over to the board to answer this question. So first of all, we must write an equation for the decomposition of sodium hydrogen triisocarbonate 4. Okay, so the chemical formula of sodium hydrogen triisocarbonate 4 is NaHCO3. Okay, so we decompose by the addition of heat, and that will give us sodium triisocarbonate 4 and carbon 4 oxide and water. Okay, so we need to balance up our equation by adding 2 here. Okay, so what this is showing us is that 2 mole of sodium hydrogen triisocarbonate 4 actually liberated, okay, 1 mole of CO2, right? So now let's calculate for the molar mass of sodium hydrogen triisocarbonate 4. So sodium hydrogen triisocarbonate 4. So let's calculate for the molar mass. So that will be 23 plus 1 for hydrogen plus 12 for carbon, okay, then plus 12 for carbon, then plus 16 times 3 for oxygen. Okay, so if we sum all this up, we'll be having, okay, this will give us, let's add this first, this will give us 24 plus 12, then plus, this will give us 48, right? So if we add all this up, okay, let's add it up gradually. This will give us 36 plus 48. Okay, so if we add this up, this will give us 84. So 84 grams per mole, right, is the molar mass of sodium hydrogen triisocarbonate 4. So 2 moles of sodium hydrogen triisocarbonate 4 will have a mass of 2 times 84, and that will produce, of course, remember that 1 mole of any gas at STP is equals to 222.4 dm cube, right? So here, what volume of this will 16 gram of sodium hydrogen triisocarbonate 4 produce? So let's call here Y, so that we just cross multiply and make Y the subject of formula, so that Y becomes 22.4 times 16.8. Of course, 2 times 84, right? That will give us 168. So let's break this down so that it will be in this format. So we'll be having 22.4 times 16.8 all over. So this is that says 16.8 times 10. Okay, of course, the essence of all this is just to make our division easier for us. So 16.8 we cancel out 16.8, right? Then 10 here is 1. Then 10 here we move this our decimal point 1 place to our left, so that our answer becomes 2.24. Okay, 2.24 dm cube, because we are dealing with volume. Okay, so our answer is 2.24 dm cube. So let's move over to the screen to pick the correct option. Okay, so from our calculation we got 2.24 dm cube. So that makes option C the correct answer to this question, 2.24 dm cube. Question 5. 300 centimeter cube of gas has a pressure of 800 millimeter mercury. If the pressure is reduced to 650 millimeter mercury, find its volume. So let's move over to the board to solve this question. So these are the information that are given to us in the question. Okay, and this is a typical Boyle's law problem. Okay, and we know that according to Boyle's law, P1 V1 is equals to P2 V2. So we just plug in our values into this formula. So we know that our P1 is equals to 800 times V1, which is 300, is equals to P2 is 650, then times V2. So what we are looking for. So we make V2 the subject of formula, so that we'll be having 800 times 300 all over 650. So 0 will cancel out 0, right? So if we multiply this out, this will give us 24, then 0, 0. 2,400 divided by 65. And this will be equals to 369.23 centimeter cube. So let's move over quickly to the screen to pick the correct option. So from our calculation, we got 369.23 centimeter cube. So that makes option B the correct option. Question 6. Diffusion is slowest in solid particles than in particles of liquid and gases because solid particles have more kinetic energy than the particles of liquid and gases. B. Solid particles have less kinetic energy than the particles of liquid and gases. C. Solid particles have less restriction in their movement than liquid and gas particles. D. The particles in solids are far apart and the cohesive forces between them are negligible. So the answer to this question is option B. Solid particles have less kinetic energy than the particles of liquid and gases. And the reason is because the particles of solid are closely packed together. Hence, they are not free to move about when compared to the particles of liquid and gases. Hence, the rate of diffusion of solid particle is lowest when compared to that of liquid and gases. So option B is the correct option. Question 7. The experiment that shows that atoms have tiny positively charged nucleus was first carried out by dash A. Mosley. Okay, so Mosley is the scientist that showed through experiment that the major properties of the atoms of an element depend on its atomic number. Okay, so this is not the answer to this question. Why option B, Rutherford, okay, was the scientist who actually carried out the experiment that shows that atoms have tiny positively charged nuclei, okay, in his Goldfall experiment. While Millikan was the one who carried out the famous oil drop experiment, where he was able to determine the size of electrons charged. Okay, Dalton was the one who put up the Dalton's atomic theory, where he said that matters are composed of small indivisible particles called atom. So the answer to this question is option B, Rutherford. Question 8. The atom of an element S is represented by this symbol. The basic chemical properties of S depends on the value of dash A, Y, B, Z, C, Y minus Z, D, Z minus Y. So first of all, let's interpret what these letters mean. So this is just how an element is represented. Okay, so Y stands for mass number and Z stands for atomic number. Okay, and looking at what we have here, this actually shows us that this atom of this element is neutral. Okay, meaning the number of proton is equal to the number of electron, which is our Z here. Okay, so the basic chemical property of an element actually depends on what? On Z. Okay, so that makes option B the correct option. The diagram above represents the electron sublevel for A, carbon, B, nitrogen, C, oxygen, D, fluorine. Okay, so each of these arrows in this diagram actually represent electron. Okay, and the number of electron in each subshell must be 2. Okay, the maximum number of electrons in each subshells, okay, are 2. okay, and each of those electrons must not have the same direction, okay, they don't have the same spin quantum number, okay, that's why we have one of the arrows facing up and another one facing down. But remember that each of these arrows represent number of electrons, so if we count, we'll be actually having 8, okay, and if looking at this, what we are seeing here is showing us that the element they are trying to describe here is neutral, meaning that the atomic number of the element is 8, okay, and the element that has atomic number of 8 is oxygen. So that makes the answer to this question C, oxygen. In the periodic table, the electrical and thermal conductivities are properties of elements that dash. A decreases across the period and increases down the group. B increases across the period and decrease down the group. C decreases across the period and down the group. D increases across the period and down the group. So the answer to this question is option A. Okay, so in the periodic table, the electrical and thermal conductivity are properties of elements that decreases across the period. Okay, the reason for that is because the atomic radius of element decreases across the period. Okay, and another reason is because of stronger electron repulsion. So this causes, or this makes, the electrical and thermal conductivity properties of element to decrease across the period and increases down the group because of increased atomic size and a loosely held outer electron. Okay, so that is the reason why the electrical and the thermal conductivity of elements increases down the group. So option A is the correct answer. The reaction above is an example of that. Nuclear fission. No, in nuclear fission, a heavy nuclei is broken down into two lighter ones. Okay, while B, we have nuclear fusion. In nuclear fusion, two lighter nuclei are brought together to form a heavier one. While option C, we have artificial transmutation. Okay, so the answer to this question is option C. Artificial transmutation is also known as artificial radioactivity. Okay, so artificial transmutation occurs when the nucleus of an element is bombarded with subatomic particles like neutron, like proton, okay, or electron. Right, so that makes option C the correct answer to this question. Air boiled out of water as steam is richer in dash. A, nitrogen and oxygen. B, carbon 4 oxide and oxygen. C, noble gases and carbon 4 oxide. D, oxygen and noble gases. So the answer to this question is carbon 4 oxide and oxygen. Okay, most water contain dissolved air. So when the water is heated, okay, the dissolved air inside escapes, okay, in form of carbon 4 oxide and oxygen. So that makes B the correct option to this question. In the course of purifying water for tank supply, the water is passed through large settling tanks containing sodium aluminate 3 to remove A, large particle, B, germs, C, fine particles, and D, odors. Okay, so the answer to this question is option C. Okay, so water for tank supply is passed through large settling tanks containing sodium aluminate in order to remove large particles. Okay, so the sodium aluminate will cause the fine particles inside the waters to clump together, okay, to form a larger particle which is able to settle at the base of the water tank, which can then be filtered off. So option C is the correct answer to this question. Do you know that you can take practice question with our simulated JAMB CBT past question? All you need to do is to click on the link in the description below, and that will take you to my school website. There, you have to download my school mobile app for your Android devices and my school software for your laptops and computer. Please go ahead and start practicing. When a few drops of water is added to a blue anhydrous cobalt 2 chloride, the color changes to dash. A, white, B, pink, C, red, and D, blue. So there are actually two reagents that are normally used in the laboratory to detect the presence of water in a substance. Okay, and one of them is white anhydrous copper 2 tetrasulfate 6, and the other one is blue cobalt 2 chloride. Okay, when an anhydrous cobalt 2 chloride comes in contact with water, the color changes from blue to pink. Okay, so that makes option B the correct option. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we release the next video. The vulcanizer solution is prepared by dissolving rubber in dash. A, ethanol. No. Rubber is not soluble in ethanol, so it cannot form a solution. Okay, B, kerosene. Rubber is not soluble in kerosene, so it cannot form a solution. C, benzene. Rubber is very, very soluble in benzene to form a solution. Okay, and we must not forget that benzene is an aromatic compound. Okay, while D, petrol. Rubber is not also soluble in petrol. So that makes option C, benzene, the correct answer to this question. 117.0 gram of sodium chloride was dissolved in 1.0 dm cube of distilled water at 25 degrees Celsius. Determine the solubility in mole per dm cube of sodium chloride at that temperature. So let's quickly move over to the board. So the formula for calculating solubility in mole per dm cube. Okay, solubility in mole per dm cube. Okay, mole per dm cube is giving us mass of salt all over molar mass of salt. Okay, all over molar mass, then times 1000 centimeter cube all over volume of solvent, right? All over volume of solvent. Okay, so but in this question we are given the volume of water in dm cube. Okay, so that means we don't actually need this 1000 centimeter cube. The reason why we normally use this 1000 centimeter cube is because we normally use it because we are trying to convert our volume, okay, of water or of solvent that is given to us in centimeter cube. But in this question we are given this volume in dm cube, so we don't actually need this 1000 centimeter cube. So we just substitute our value. So mass of gas is 17.0 all over molar mass of sodium chloride. Of course, sodium chloride is the salt. So the molar mass of sodium chloride is, sodium is 23, then chlorine is 35.5. So if we sum this up together, that will give us 58.5 grams per mole. Okay, so the molar mass of sodium chloride is 58.5. Okay, then times volume of water, which is given to us to be 1 dm cube. So we multiply this by 1. So if we divide, this will give us 2.0 mole per dm cube. Okay, so this is the solubility of the salt at 25 degrees Celsius. So let's move over to the screen to pick the correct option. Okay, so from our calculation, the solubility of sodium chloride at that temperature, 25 degrees Celsius, was 2. Okay, so that makes option B the correct answer, 2. The uncovered raw food that is sold along major roads is likely to contain some amount of dash: A, lead; B, copper; C, silver; and D, sodium. Okay, so the answer to this question is option A, lead. And the reason for that is because of the smoke from the exhaust of vehicles, okay, that incorporates tail, okay, as an anti-knock agent, okay, in order to improve fuel consumptions in their car engine. Some lead particles are released, okay, as smoke, and these particles land on food that are sold along the road. Okay, but because of the negative effect of lead, okay, its use as an anti-knock agent is being discouraged by many countries. Okay, but the answer to this question is option A, lead. What is the pH of 0.001 mole dm cube solution of sodium hydroxide? So let's quickly move over to the board to solve that question. Okay, we know that H, hydrogen ion times hydroxy ion is equals to 10 raised to power minus 14. Okay, but from the question we are given that hydroxy ion is equals to 0.001 mole dm cube, okay, which is written as 10 raised to power minus 3. So we just substitute hydrogen ion times 10 raised to power minus 3 is equals to 10 raised to power minus 14. So we divide both sides by the coefficient of hydrogen ion, so which will be equals to 10 raised to power minus 14 divided by 10 raised to power minus 3. So this will be equals, according to law of indices, this becomes 10 raised to power minus 14 plus 3. So our answer becomes 10 raised to power minus 11. Okay, but in this question we are asked to calculate pH, and pH is equals to minus log base 10 to hydrogen ion concentration. So we just substitute, since our hydrogen ion concentration equals to 10 raised to power minus 11. So minus log base 10, then raised to power 10 raised to power minus 11, right? So according to the law of logarithm, this minus 11 is going to come behind. So that I'll be having minus 1 times minus 11, then log 10 base 10. And log 10 base 10 is equals to 1. So that minus 1 times minus 11 is equals to 11. So let's move over to the screen to pick the correct option. Okay, so from our calculation, we got 11. So the correct answer to this question is option D, 11. The basicity of ethanoic acid is dash. The basicity of an acid simply means the number of replaceable hydrogen atom in one molecule of that acid. Okay, so the basicity of ethanoic acid is 1. The reason is because basicity is a weak acid. So when it ionizes in water, you only have one hydrogen ion. Okay, and the hydrogen that is replaceable here is the one attached to the carboxy part of this compound. Okay, why this 3 here is non-ionizable, it's not replaceable. Okay, because they are covalently bonded to the carbon atom here. So that makes option A the correct answer to this question. 0.05 mol dm cube hydrochloric acid is neutralized by 25 centimeter cube sodium hydroxide. If the volume of acid used is 32.00 centimeter cube, what is the concentration of the base? So let's move over to the board. So first of all, if we are given questions like this, first thing to do is to write a balance equation for the two substances that are involved in the question. Okay, so in this question, we have hydrochloric acid reacting with sodium hydroxide. Okay, so this is a typical neutralization reaction. Okay, so this will produce a salt, sodium hydroxide, and also water. Okay, so I think our equation is balanced. Okay, so using this formula, CaVb all over CaVa all over CbVb is equals to number of mole of acid all over number of mole of base. Okay, AC stands for the concentration of the acid, while Cb stands for the concentration of the base, Va here the volume of the acid, while Vb here the volume of the base. Okay, Na here means the number of mole of the acid, Y here means the number of mole of the base. So from our equation, we have 1 mole of acid and 1 mole of base. Okay, so since we are calculating for the concentration of the base, we just impute our formulas and make Cb the subject of formula. Okay, so here we'll be having 0.05 times 32 all over Cb times times 25. Okay, it's equals to 1 over 1. So if we cross multiply, we'll be having Cb times 25 is equals to 0.05 times 32. So Cb is equals to 0.05 times 32 divided by 25. So this will be equals to 0.064 mole per dm cube. Okay, so let's move over to the screen to pick the correct answer. So from our calculation, we actually got 0.064 dm cube, okay, as the concentration of the base. So that makes option D the correct option. Question 21. Insoluble salts can be prepared by titrating an alkali against an appropriate acid. B. Reacting an acid with triisocarbonate 4 salt. C. Direct combination of the elements which make up the salt. D. Missing 2 soluble compounds containing the metallic radical and the acidic radical. Okay, so the answer to this question is option D. Of course, we have 2 methods of preparing an insoluble salt. Okay, one is by double decomposition and the other one is by direct combination of the constituent elements, okay, that made up that salt. Direct combination of the elements which made up the salt. Okay, but the answer to this question, option D, is more complete. Okay, because when we say direct combination of elements which made up the salt, we can as well still combine 2 elements. For example, we can combine sodium and chlorine to form sodium chloride, which is a soluble salt. Okay, so option D is more specific. Okay, so during this process, missing 2 soluble compounds containing metallic radical and acidic radical, there's an exchange of radicals between these 2 salts to produce one salt that is soluble and to produce one that is insoluble. So that salt that is insoluble is gotten by through filtration. Okay, a good example is the reaction of sodium chloride with silver triisonitrate 5, okay, to produce silver chloride, which is an insoluble salt, and sodium triisonitrate 5 okay, which is a soluble salt. So option D is a more complete or is a more correct option than option C. Do you have questions to ask? Please feel free to ask your question by clicking on the link in the description below, and this will take you to my school website. There you can ask all your questions and solution will be provided to all your questions within a short time. Moving on to question 22. The oxidation state of carbon in methanoic acid is dash. Okay, so this is methanoic acid. Okay, so the oxidation state of carbon in methanoic acid is dash. Okay, of course, we must remember that the oxidation state of a neutral compound, okay, is equals to 0, and it's simply the combination of the oxidation state of all the elements that made up that compound. Okay, so let's move over to the board to provide solution to this problem. Okay, so this is methanoic acid, and we are asked to find the oxidation number or the oxidation state, of carbon in this compound. Okay, so we know that the oxidation state of hydrogen is 1, so here we have 1, then plus carbon, the one we are looking for, then we leave it, then plus we know that the oxidation state of oxygen is -2. Okay, and we have 2 oxygens here, so we just go -2 times 2. Then our hydrogen is also 1, so I should have combined everything. Okay, so this equals to 0. So 1 plus 1, that will give us 2, then plus C, then this will give us -4 is equals to 0. So that C will be -2 is equals to 0. So we move this -2 to the other side, so that C is now equals to 2. So the oxidation state of carbon in this compound, methanoic acid, is 2. So let's move over to the screen to pick the correct option. Okay, and the option is staring at us in the face, which is B. So the answer to this question is B. Do you have better explanation or step to any of this question? Kindly go to the comment section below and comment the question number and the solution you wish to share. Question 23. What is the IUPAC nomenclature of the compound NaClO? So let's move over to the board. Let me show you how to do that. So this is the compound that is given to us, okay, that we should name. Okay, so here our attention should be first of all based on this. We must know the oxidation state of chlorine, which is the middle element in this compound. We must know the oxidation state. Okay, so to do that is just for us to calculate for the oxidation number of this compound, and the reason for that is that in our naming the oxidation number is going to come last. Okay, so it's still part of the naming. That's why we have to first of all calculate for the oxidation number. So I'm just doing all this for the sake of those who doesn't know how to do it. Okay, we know that the oxidation state of sodium is, or the oxidation number of sodium is 1. Okay, then plus Cl, and that of oxygen is -2. Of course, everything equals to 0. Okay, for a compound. Now Cl, now in that case we'll be having -1 is equals to 0. Okay, because 1 minus 2 will give us -1 equals to 0. So that Cl is equals to 1. The oxidation state of chlorine, okay, in this compound is 1. So let's name it. Now when you are naming, first of all, start with the metal here. Okay, so the metal we have here is sodium. So we go sodium. Then you move down to the last compound here. So the compound that we have here is oxygen, and we only have 1. So you can go mono-ozo, or you can just go ozo. So in this case, let's go ozo, depending on the option that we have on the screen though. So we have ozo. Then the next one is your chlorine. Okay, but in this case, your chlorine will end with ATE. So in that case, become chlorate. Okay, chlorate. Then you indicate the oxidation number of chlorine, which is 1. Okay, so this question, this compound is actually sodium orthochlorate 1. So let's move over to the screen and check our option if we have anything like that. So in the first option we have sodium orthochlorate 1, which agrees with what we did on the board. So option A is the correct option. Okay, but if you look at option C could have as well be the answer, but the only difference is because of these 2. Okay, so the oxidation state of chlorine in this compound is not 2, but it's actually 1. But had it been is 1, then these 2 would have been the same. Okay, but option A is the correct option because it's 1. The oxidation state of chlorine is 1, not 2. Question 24. In recharging a lead acid accumulator, the reaction at the cathode can be represented as Okay, so during the process of recharging a lead acid accumulator, the redox reaction at the respective electrodes are reversed. Okay, this is because it is electrolysis. So the cathode, okay, during the discharge process becomes the anode during the recharge process. So the electrolyte, which is lead tetrasulfate 6 at the cathode, breaks down into lead ion and tetrasulfate 6 ion. So the lead ion acquires 2 electrons to become neutral lead. So that makes option B the correct option. Question 25. If a given quantity of electricity liberates 0.65 gram of zinc ion, what amount of mercury ion would be liberated by the same quantity of current? So let's move over to the board to solve that question. Okay, so zinc ion, okay, plus 2 electron, that will give us zinc. Okay, so from here we know that the molar mass of zinc here, we know that 1 mole of zinc, okay, 1 mole of zinc will be liberated by 2 Faradays. Okay, so that 65 grams of zinc will be liberated by 2 Faraday. So what about 0.65 gram? How many Faraday, or what is the quantity of electricity that will be liberated by 0.6 Faraday? So let's call here X. So we cross multiply so that S is equals to 2 Faraday times 0.65 divided by 65. And this is equals to 0.02 Faraday. Okay. So now let's move over to the second part of the question. They said, what amount of mercury ion will be liberated by the same quantity of current? Okay, so we know that a mercury ion, H2 plus, will also be liberated by 2 Faraday. Okay, so mercury, which is 201 gram, will be liberated by 2 Faraday. So what mass will be liberated? So here will be X, will be liberated by 0.02 Faraday. Okay, so we just cross multiply. So if we cross multiply, we'll be having X is equals to, okay, let's call here Y. So Y will be equals to 201 times 0.02 Faraday divided by 2 Faraday. So Faraday, F will cancel out F, so that this will be equals to 2.01 gram. Okay, so let's move over to the screen to pick the correct option. Okay, so from our calculation, the correct option is option B, 2.01 gram. I believe you are enjoying this video content. If yes, please do not forget to hit the like button, click on the subscribe button, and lastly, tap on the notification bell to get informed as soon as we upload the next videos.